Hmm. Interesting, right? How do aircraft fly? What are the principles behind it? Aircrafts are classified as lighter than air and heavier than air. Lighter than air aircrafts fly based on the principle of Archimedes. Archimedes' principle states that the upward force exerted on a partially or fully immersed object in a fluid is equal to the weight of the fluid displaced by it. Therefore, object of same weight occupying large volume of fluid experiences greater upward force or buoyancy. Here, fluid is air and object is airship or hot air balloon. In order to lift off an airship or hot air balloon, the minimum upward force required should be greater than its own weight. Therefore, the balloon is sized so huge that it covers large volume to get sufficient upward force in agreement with Archimedes' principle. Now that we know Archimedes' principle, let's define lighter than air and heavier than air aircrafts. As the name suggests, lighter than air aircrafts are aircrafts which weigh less than the air that it displaces, and heavier than air aircrafts are aircrafts which weigh more than the air that it displaces. Hence, heavier than air aircrafts obtain lift by aerodynamic means. Heavier than air aircraft's flight can be explained through Bernoulli's principle, Newton's laws of motion, and Navier-Stokes equation. Bernoulli's principle states that increase in the speed of fluid occurs simultaneously with decrease in pressure or decrease in fluid's potential energy, that is, sum of potential, kinetic, and pressure energy per unit volume is always conserved. Hence, when air flows past the wing or any lift generating surface, the pressure is lower on the side where velocity of fluid is greater. Here, it is the upper surface of wing, and on the other hand, pressure is higher where the velocity of fluid is low. Here, it is the lower surface of wing, hence generating lift. Bernoulli's principle is only defined for an inviscid, incompressible, and steady flow. That is, velocity, density, and other fluid properties cannot change at a point with time. The more realistic form of equation is given by Navier-Stokes, where viscosity of fluid, change in density, and change in pressure with respect to time is taken into account. Navier-Stokes equation. Oh, I know, equation looks frightening. Even I was taken aback the first time. Now to make it simpler, given equation can be seen in the form of Newton's second law of motion, that is, F is equal to ma. For fluid dynamics in controlled volume, equation becomes density times acceleration, and the change of velocity is local acceleration. Convective term or convective acceleration is the rate of change of velocity with respect to particles. Pressure term is the force due to difference in pressure. Body force term is force due to external agents like gravity. Viscosity controlled velocity diffusion term is the viscous force. So, this equation can be simplified to sum of all forces is equal to the mass times acceleration. From third law, every action has an equal and opposite reaction to it. Air exiting at the end of trailing edge exerts equal and opposite force to the flow of air, adding to the thrust or lift accordingly. Newton's first and second law are also in effect. Let me just brief about it. In accordance with Newton's first law of motion, also known as law of inertia, aircraft changes its state of motion using thrust and control surfaces. In accordance with Newton's second law of motion, also known as law of momentum, acceleration of aircraft is proportional to the forces applied by thrust and inversely proportional to the mass of aircraft. Since it is known that Newton's laws of motion are recurrently used and common into effect in numerous kinematics, it is entirely understood. Hence, it has been explained briefly in this video. Also, there are many theories explaining principles of flight, and these are most widely accepted. However, For in-depth details about principles and laws explained, visit our website which is linked in the description below.